All right, we're going to do a little more SAT prep. We are doing 2.3.19, which is practice test 2, section 3, number 19 on page 464. All right, so I drew a picture poorly of the diagram that we're given. In the figure here, QR is the arc of a circle with center at P. If the length of the arc QR is 6 pi, what is the area of sector PQR? Okay, so let's first talk about what a sector is, right? We need a little bit of knowledge about what a circle looks like. So your circle is a pizza, right? A sector is a slice, right? So a sector starts at the center and is a slice of pizza, and it can be varying sizes. You could have a sector like this. You could have a sector that's a quarter of the circle, right? You could have a sector that's a whole half the circle, right? You could be like, hey, cool, bro, that's my half of the pizza, right? That could be a sector. So a sector is essentially a slice of pizza, and what size slice you get just depends on how generous the person cutting the pizza is. So when we talk about circles and sectors, we should understand the concept of the length of the arcs in the sectors and also the area. So because this is just a slice of the pizza, right, the area of a full pizza is pi r squared. The area of a sector, which I'm going to call a sub s, right, is whatever the angle is at the middle that I'm going to call theta over 360, right, times pi r squared. And the reason for that is that if, for instance, if I had given you half the pizza, if this had been the full 180 degrees, then you'd be looking at half the pizza. Well, we can logic that this is half the pizza, right? But the math behind it being the half the pizza is that I gave you 180 degrees out of the total 360 degrees that exist in a circle. So why is this a theta over 360 degrees? Well, that's how we can figure out what fraction of the circle we're looking at. Now, the same thing is true of the circumference, right? So the area, right, that red piece is the area of the sector. Well, the circumference of a circle is the whole measure around, right? And the circumference of a circle is 2 pi r, right? But if you only wanted this chunk that we're going to call arc length, so I'm going to call CS for the circumference of that sector, meaning the arc length, well, it would be the same fraction, that theta over 360 times my 2 pi r. Because again, theta over 360 gives me the fraction of the circle I'm looking at. So the whole circumference is 2 pi r, but the fraction for that sector, the piece of crust that I'm looking at, right, this crust right here, that's only theta over 360 times the 2 pi r. So knowing that information, now let's go back and see what we know. We know that QR is 6 pi, right? So essentially what we can do is we can figure out what fraction of the circle we're looking at, right? So let's first talk about what fraction, right? What fraction of the circle. So what fraction of my pizza are we looking at, right? Well, we're looking at 30 degrees over 360 degrees, right? And if you cancel a 0, you get 3 over 36. If you cancel the 3 out of that, you get a 1/12. So essentially, you have a slice of pizza that is 1/12 of the pie, right? So I know that 6 pi is 1/12 of whatever 2 pi r should be. Right? I can use this information, so because that's the whole circumference, and this is the chunk that is only the crust of what I'm looking at, right? So if I clean this up a little bit, I get 6 pi equals a 1/6 pi r. And if I solve for r, I'm going to multiply the 6 over and divide by pi, and I'm going to get 36 equals r, right? Once I know that 36 is my r, right? Now that I have 36 as r, I can now figure out first the circumference of the entire thing if I want. I'm sorry, not the circumference, rather the area of the whole thing. And then figure out what 1/12 of that is. Or I can just skip to this formula right here and say, wait a second, I know I want 1/12 of the area, right? So I think that the best bet here is if I erase here and give you a little bit more work at the top. So I want 1/12 of the area. Well, now that I know what r is, the area of this sector that I'm looking at is that 1/12, right? Because the 30 over 360. Pi times the 36 squared, right? And you can do 36 squared, and there's certainly nothing wrong with that. If you want to do 36 squared, it's a calculator acceptable problem, but I'm going to argue it's easier to recognize that you have a 36 times a 36 all over a 12. I'm going to cancel the 12 with one of the 36s and get a 3. So I end up getting a 108 pi as the chunk of the circle I'm looking at, right? So the area of that one sector that I'm looking at, which I called A sub s, is 108 pi, which is answer A.